Welcome to Mr. Source tutorial. Today we're going to be considering Kirchhoff law. Yes, Kirchhoff law basically has two parts. We have a Kirchhoff voltage law, and we have Kirchhoff current law. Kirchhoff voltage law is used for mesh analysis, basically, while Kirchhoff current law is used for node analysis, basically, as is stated there. But let's consider Kirchhoff voltage law first as a subheading. Kirchhoff voltage law states that the sum of voltages plus the algebraic sum of voltage drop in the any closed path or network is equals to 0. You can see that the total sum of voltage here is V. You can call it V total, and this voltage drop at the resistor R1 is known as V1, while the voltage drop at resistor R2 is known as V2. So the algebraic sum of voltages, that is, so far you know the sign convention of voltage source, that is minus V total plus voltage drop at R1, which is V1, plus voltage drop at R2, which is V2, is equal to 0. Kirchhoff current law states that the algebraic sum of currents going inside the node, remember this is a node where two or more components in the circuit meets. The algebraic sum of current going inside the nodes is equal to the algebraic sum of current going out of the nodes. As you can see from this current, the direction of flow of current is given as this. I1 is going in, I2 is going in, I3 is going in, I5 is going out, I6 is going in, I4 is going out, sorry. So now what we have here is I1 going in plus I2 going in plus I3 going in plus I6 going in equals to I4 going out plus I5 going out. That's KCL. That's KCL. So that's how it's given. This is called KCL equation. What is called KVL equation. For this video, we are considering specifically mesh analysis. Later on, we are going to treat nodal analysis effectively. So let's consider a simple network like this. Now I want to find the mesh current. We call it I1 and I2. There are some steps you need to take in finding that. The first step is for you to assign the current at each mesh. This is mesh 1, current clockwise direction I1, and mesh 2, same direction I2. After assign the current direction, what you need to do first, secondly, is for you to derive the KVL equation. Now, by applying KVL, to derive the KVL equation, you need to understand some things, which is a very basic. Remember that current always flow from instead of higher potential, sorry, from lower potential to higher potential. Right? Now, if this current is flowing from negative to positive, this V1 sign will carry a negative sign. But if it's flowing in the inverse direction, that is from positive to negative, to carry a positive sign. So it means that our V1 here automatically is carrying a negative sign because it's flowing from negative to positive, which is the same direction of current. That's how we have this V1 to be minus, plus the voltage drop here is I1 times R1, which is, remember that voltage V equals to IR, which is called voltage drop, and it's also known as Ohm's law, also known as voltage drop. Yes. So now this voltage drop at this point is given as I1 R1, while voltage drop at this point, remember that this R3 is lying between mesh 1 and mesh 2. Because you're considering mesh 1, you're going to have this I3 outside, open bracket, I1 minus I2, because you're considering mesh 1. We don't have any component here, and it says equal to 0. Now what you need to do next is for us to move this V1 to the right hand side. and open the bracket here. So this time this give us this time this give us this. Now this move to this side, return negative v1, move to this side, return positive v1. You can see that I1 and I1 is common here. Factor out I1 outside, you have this. So minus this equals equation 1. Now applying a KVL also to mesh 2. Look at the mesh 2 here. As you can see, this voltage V2 is flowing from a positive to negative, which is the inverse of the direction of current. So that's why we have this place to be positive. And this resistor R3 is lying between mesh 1 and mesh 2. But this one is positive as stated. Positive here. And this one, because you're at mesh 2, I'm going to say I2 and current in mesh 2 and current in mesh 1 plus, because voltage drop is I2 R2 equals to 0. The same step as we just did before. Move this positive V2 to the right hand side, you have negative V2. Open this bracket, this and you give this and you give this. That's correct. So now we now arrange and collect like terms. Now take I2 and I2, factor out I2 outside, and have the result. You now recall equation 1 and equation 2. This is your equation 1, which is what you have here. Equation 2, which is what you have here. Having solved this to this point, you now apply any simultaneous method formula, which is substitution method, determinant method, which is matrix method, and also elimination method. You can also use that to find the value for your I1 and I2. Having learned the basic concept of mesh analysis, this is a two mesh network which result in a two simultaneous equation. So applying KVL as what we did before as usual to mesh 1, seeing that this 5 volts voltage source has a positive potential flowing this way and the current flowing through the same direction, so that's why we have a negative 45 volt. The voltage drop here is I1 times 2, give it to I1, while the voltage drop at this resistor, 12 ohm resistor that is lying between mesh 1 and mesh 2, is given as 12 into I1 minus I2, because you're considering mesh 1. So at this point now, the voltage drop here is given as 4 times I1, give you 4 I1 equals to 0 as that. So what you need to do next is for you to move this minus 45 to the right hand side, will give you positive 45. Bringing down this one as it is here, and open this bracket, 12 times I1 give you 12 I1, 12 times minus I2 will give you minus 12 I2 plus 4 I1 equals to 45. Look at it, you see that you have I1 here, I1 here, and I1 here. Collecting the item and summing it together, you have this 18 I1, and this 12 minus 12 I2 is still there, equals to 45. That's called equation 1. Now I'm going to equation 2. You consider mesh 2. These are mesh 2, as shown there. Yes. So at this mesh 2 now, you see that this 30 volts is flowing in the inverse direction as the direction of current. That is, it's flowing this way, while current flowing this way. So it's positive, just as you have it here. And the voltage drop here is I2 times 3, will give you 3 I2. And the voltage drop at this point is because this point is showing the node between mesh 1 and mesh 2. So you have 12 into I2 minus I1. The next resistor value here is the next resistor value is a 9 ohm resistor, which is what you have here. Okay, so this was a 9 ohm resistor. Sorry. Okay, having known that, in the same procedure what we did before, we now open this bracket by saying this time this give you this time this give you this. This one is written here as this one is here. I move this 30 to the right hand side, you have minus 30 there. Yes, that's correct. Minus 30 there. And arrange it. I1 is here. You see that I2, if you have I2 here, you have I2 here, and we have I2 here. 3 plus 12 plus 9 give us 24, and the minus 12 I1 is still there, equals to minus 30. Recall equation 1 and equation 2, which is equation 1 and equation 2 it is. Solving it simultaneously which is a very pretty simple. You can use matrix method to solve it. You can use the measurement method to solve it, but here I want to use this my calculator to do a simple calculation. What you need to do here is first is for me to check my mode setup, press equation 5, press number 1 this. Now putting in the parameter values, I have 18 here, press 18 equals to press minus 12 equal to press 45 equal to I press minus 12 equal to I press 24 equals to and I press minus 30 equals to I have my I1 to be equals to I1 equals to 2.5 ampere and my I2 equals to 0 ampere. So it means that the current in I1 is equals to 5 ampere, current in I2 equals to 0 ampere, which is very correct. To check if you are very correct, put the value for I1 here, put the value for I2 here, it must give you 45. The same thing applicable here, put the value for I1 here, value for I2 here, it must give you 30. Thank you very much.